All right, the SOH TOA friendly review. First thing we want to do is find this side down here, and that's going to be Pythagorean theorem. So that's going to be 5 squared minus 3 squared. And when we type that into the calculator, we get a 4. That would land us there. Once we get that 4, and we have the 3, 4, 5, we know that the hypotenuse is 5. So from SO of SOH TOA, the hypotenuse must go on the bottom. We also know that from CAH, adjacent over hypotenuse, that the hypotenuse must go on the bottom. And we're going to determine what the opposite side is from theta. The opposite side would be this 3. That would be my OPP, my opposite side. And then my adjacent side would be right next to theta. A lot of people think that 5 is right next to it. 5 is right next to it, but 5 is also considered the longest side, or the hypotenuse. So I have my opposite, which is 3 over 5. I have my adjacent, which is 4 over 5. And then notice, I can look at the TOA version of this, which is opposite over adjacent, or I can just look at my 3 and my 4, and notice that opposite over adjacent will always be this top number over this top number from the sine and cosine, 3 over 4. Now we're going to do the cosecant, which is the reciprocal function, so that's going to be the reciprocal. We're going to do secant, which is the reciprocal function, so we just do the reciprocal, and we do the reciprocal. Cotangent is the reciprocal function of tangent, 4 over 3. Now to find theta, what I would like to do is use the inverse sign. So theta in degrees, this angle in degrees is going to equal the arc sine of 3 over 5. And when I type that into the calculator, I have to be in degree mode. And when I type that into my calculator, I get approximately 36.86986. So we're just going to round it to 37 degrees. Now to find omega. Now, if this angle is 37 degrees, this angle is 90 degrees, there's 180 degrees in the triangle, so I do 180 minus 90 minus 37. Or you just notice that it's just going to be 90 minus 37 to give me omega. And that's going to generate a 53-degree angle. 8, 15, this is going to be the opposite. This is going to be the adjacent. It's opposite. This is adjacent. This side will be the hypotenuse. Now, because I'm seeking out the hypotenuse, I'm going to add the 8 and 15 in the Pythagorean theorem. So that's going to give me 15 squared plus 8 squared. And when I type that into the calculator, just like it looks, the calculator key in, that's going to give me a hypotenuse of 17. Now, from SOH TOA, I really like to generate that 17 on the bottom as quickly as I can. From the CAH, that 17 is the hypotenuse. It goes on the bottom. The TOA doesn't have a hypotenuse. So I'm going to take the opposite from the O, the opposite, the OPP is going to be 8 over 17. The only number left over to deal with is the 15. And then opposite over adjacent, notice it could be 8 over 15, or we can just look at this 8 and look at this 15 and write it as 8 over 15. Now I'm going to do the reciprocal function, so this is going to be 17 over 8. This is going to be 17 over 15. And this is going to be 15 over 8. Theta, I'm going to use the arc sine to find the degrees. Theta in degrees equals arc sine of 8 over 17. In degree mode, please. Oops, I forgot to put the 17 there. And that's going to give me 28 degrees after I round it. 28 degrees, nearest whole degree. To find gamma, that's going to be 90 minus 28. And that will generate a 62-degree angle. Number 3, notice I don't have anything on the triangle, but I have a 41 and a 9 over here. So the reciprocal is going to give me the sine, which is 9 over 41. And that's the sine function, and we know that sine is opposite over hypotenuse. So this means 41 must be my hypotenuse, my longest side. Opposite is going to be over this side, my OPP. And that's going to be 9. And now I have to use Pythagorean theorem to find my adjacent side, which is going to be the hypotenuse squared minus that leg squared, and that's going to equal 40 when I type it into the calculator. So I have the 40 here. Now I have a 9 and a 41. I should know that the 41, the hypotenuse has to go on the bottom. The 40 is the only thing that's left over, and that's adjacent over hypotenuse, if I use the CAH notation. Adjacent, 40 over the hypotenuse of 41. The tangent is going to be 9 over 40. Or we can look at it as 9 over 40 at this side. Reciprocal functions, 41 over 40. 40 over 9. And I don't ask for any of the angles. Coordinate plane, or Cartesian, after Rene Descartes. So I go right 3, up 4, and I plot that coordinate. Now I'm going to draw the radius, or the hypotenuse. And you must be careful. When you draw your reference triangle, it's got to be perpendicular to the x-axis. Not the y, no, over here. We need it on the x-axis. I'm going to draw my right angle and theta, because we are looking for theta in this problem as well. And now we can label it. The hypotenuse is going to be this long side, or the radius. The opposite is going to be over there. And adjacent is going to be this base. Notice I went right 3, so this length is going to give me 3. This height is going to give me 4. When we throw it into the Pythagorean theorem, 3 squared plus 4 squared, it's going to generate that hypotenuse of 5. And I like to go rapidly, knowing that the hypotenuse goes on the bottom. The hypotenuse goes on the bottom. Now, I can get my opposite, which is 4. And that goes over the 5. My adjacent, which is 3. And my tangent, which is opposite over adjacent, 4 over 3. Or we can just look at this 4 up here, and this 3 down here, 4 over 3. It works out nicely. Reciprocal functions, 5 over 4, 5 over 3, and 3 over 4. Theta, we're going to use arc sine. Theta degrees equals the arc sine of 4 divided by 5. And again, that gives me 53 degrees. Number 5, this one's going to give me radical answers. This one's a little bit of a challenge. So I plot the coordinate 2, 1, 2, 3. I draw my radius, which is my hypotenuse. Now I have to draw the triangle, the straight triangle. No, I don't want to go to the y-axis. I want to go down to the x-axis. Let's make that abundantly clear. Now I'm going to label this as my right angle, and my theta goes here. Let's see what happens. I went right 2, and I went up 3. I need to find my hypotenuse. That's going to be tough. That's going to be the square root of 2 squared plus 3 squared. In my calculator, that's going to generate a radical of 4 plus 9, or root 13. And we want to leave it in radical form. Square root 13. So Catella says the square root of 13 goes on the bottom. The square root of 13 goes on the bottom. Opposite. Theta is going to be 3. So it's going to be 3 over root 13. Adjacent is going to be 2. 3 over 2. Opposite over adjacent. Reciprocal functions. Root 13 over 3. Reciprocal function. Root 13 over 2. Reciprocal function. 2 over 3. Now, in calculus, you do not have to simplify this radical. But in pre-calculus, we do. And when I simplify that, that's going to give me 3 root 13 over 13. 2 root 13 over 13 as my simplified answer. You could just type that into the calculator and it will generate the correct answer. Alright, special right triangles. In your journal, you have this wonderful note that has this right triangle with a 30, 60, 90, and this right triangle, which is a 45, 45, 90, and that should help this process go pretty rapidly. So notice I have a 3 on the bottom, so I have an x over here. To get this side b, I just multiply that by 2, so that's going to be 2 times 3, which is 6. And then this side over here, notice it's x, it's going to be x root 3, so this side is just going to be 3 root 3. Using this algorithm, it goes pretty rapidly. I have a 3, so that's going to be x there for 3, so x is 3, and then this here is going to be 3 also, so that's going to be 3. So it goes x, x, or 3, 3, x, x, x root 2, that's going to give me 3 root 2. Again, it goes pretty rapidly. This is 4, notice if I have this side over here 4, this side is going to be half of that. So half of 4 is 2. Half of 4 is 2. And then this side over here is just going to be that base with a root 3 after it. So 2 root 3. 4, 4, 4 root 2. It should go quickly. A was 3 root 3. Be diligent. B was 6. C was 3. D was 3 root 2. E was 2. F was 2 root 3. G was 4 root 2. H was 4. Some more special right triangles. So the hypotenuse is 6. So this base is going to be half of that. Hypotenuse is 16. So the base is going to be half of that, 8. And then the long leg is going to be 8 root 3. 5, 5, 5 root 2. This side here is 7 root 3. Notice how this is something root 3. So this base is just going to be 7. This base is going to be twice that. So that's going to give me 14. But do notice it's only asking me for m, not for that side. If this side is 7, 7, 7, 7, 7 root 2. 5 root 3, 5, double that, 10. This side I'm just going to make up a number arbitrarily. I'll say that is 12. So I take half of that. That's going to give me 6. And then because it's a 45, 45, it's going to have a root 2 involved. So this side is 12, this side is 6 root 2, this side is 6 root 2, this side is 6 root 2. Again, this one, 5 root 3, 5, and the base is 10. Let's enter these answers in carefully. So J was 8 root 3. I don't have room for that, was up there, that's 8. K is 5 root 2. L is 5. M is 14. N is 7. Be careful, O is 7 root 2. P is 7. Q is 7. R is 5. S, 10. T, 6 root 2. U, 6 root 2. V, 6 root 2. W, 6 root 2. Area is length times width. So root 7 times root 14 in my calculator. It will generate a nice answer for me. I think it's going to be 7 root 7. I'm not sure. Let's see here. 7 root 2, actually. This, I need to slice it up. I like to add to it. So I'm going to add to this rectangle. The base is 12. The height is 3 plus 4 is 7. 12 times 7 is going to give me 84. So my total area has to be less than 84. Let's see, 84 minus this area here, which is 8. That'll give me 76 for that area. The shaded region, that's going to be 1/2 r squared theta, but theta has to be in radians, so it's going to be 1/2 root 6 times root 6 is 6 over 1. Theta in radians, 45 degrees in radians on the unit circle is pi over 4. So I'm going to generate this into the calculator. That's going to be 6 pi over 8, and then when I simplify that, that's going to give me 3 pi over 4 as my final answer. For this one, same formula, 1/2 r squared theta. Theta has to be in degrees. Theta has to be in radians. 1/2 times root 5 is 5 over 1. 135 on the unit circle is 3 pi. That's going to give me 15 pi over 8, and I don't think I can simplify it. 15 pi over 8 is my final answer.